Okay, next part in 3.5 graphing square and cube root functions. We're going to just talk about some shortcuts basically. So hopefully you noticed all square roots of x look like a tipped over parabola, but just half of it, right? And then negative square roots of x, just flip that like this, okay? Likewise, a cube root of x is kind of like a stretched out S. Looks like this. And a negative cube root of x is just that flipped. Okay, it's my rough sketch of it. So since we know that, it turns out we have some shortcuts here. They write it in very mathy language, so let's pick this apart here. We have this y equals a times the square root of x minus h plus k, or y equals a times the cube root of x minus h plus k. Okay, so let's talk about what each of these do. They do the same thing for the cube root and the square root, so I'm just going to write above the square root. But basically this a is going to stretch or shrink your function. And actually, I don't even care about the stretching and shrinking. I'm not going to test you on that. Really what I care about is it flips it if it's negative. Flip if negative. Okay, so it will flip that over. The h, so notice h is inside the square root or the cube root. H is going to move left or right, and it will be backwards. So if h is negative, it's going to move right. If it's positive, it will move left. And then the last one here is our k, and k is going to move it up or down. And k moves like we think. Remember, it's outside the square root. If you add a number, it should move it up that many. If you subtract a number, it'll move it down that many. I did make a little Desmos thing if we want to see that. So this right here is just our basic square root function. And we can kind of play with it. So here, if I change a and I make it negative, notice it just flips it over. If I increase the value, it will stretch it out. And if I decrease the value, so if I let this go into decimals, it would shrink it. Like I said, I'm not going to test you over that. Really, I care if you notice if it's positive or negative. So then the h is the thing that's inside the square root. So that'll move it left to right. So if we make it a positive 1, notice it moves it 1 to the left. Positive 1 will move 1 to the left. A positive 2 moves it 2 to the left. And then likewise, a negative 2 will move it 2 to the right. Negative 1 will move it 1 to the right, and so on. Okay? So you can see it slides that way. And then our last one is k, and k moves just like we think it should. If you add +1 or +2, it moves it up or down, 2 or 1. If you subtract, it will move it down 1 or down 2 or down 3 or down 4, however many we subtract. Okay, so that'll be part of what we want to do. Then we also have, just so you guys see, the cube root works the same. This is just our basic cube root function. It's like that stretched out x. If we make a negative, notice it flips it. Okay, and then if we stretch it out, it makes it more stretched. Okay. If we change h, that's inside that cube root. Oops, sorry, I made that. So h moves it left or right. Again, if we subtract, so if we have a positive h, it will move it to the left, however many. If we have a negative h, it will move it to the right. Okay, so -5 moves it 5 right. +5 moves it 5 left. Pretty straightforward. And then k, same thing, it will move it up or down. I do want you guys to notice for the square root, remember the domain and range for the cube root was always all real numbers. It was pretty easy. The square root, though, we were saying it was x greater than or equal to 0, y greater than or equal to 0. But notice that changes here, right? Because our y's suddenly change. Now y, our values for y here, can actually go -3 up to positive infinity. So anything greater than or equal to -3. Or you can change what x's are allowed. If I change my h, suddenly now x has to be greater than or equal to 5 in order for it to be in the domain. So we're going to have to pay a little bit of attention to that. So let's get back to our examples. I apologize, the tables and the examples are not quite right, so we're going to have to kind of fiddle with those. So for our first function, it's -2 times x, the square root of x minus 3 plus 2. Be careful when you're typing this into your calculator. This -3 has to be under the square root. To get out of the square root from your calculator, you using that button. If you have one of the old calculators where it types the square root like this and then you have a parenthesis, all you have to do is close the parenthesis. So it depends on which calculator you have. Once you've typed this in, I do want to change the table, and like I said, I apologize for this table not being quite right. You can actually just erase these values using a white pencil. And then we have to add a couple values on. So I'm going to put 2 here, 3, 4, 5, 6, and 7. So if you look in your table, 2 is actually an error, okay? And that makes sense because if you look here, we're adding 2, so our transformation is to move up 2, okay? Likewise here, we have a minus 3. That's going to move it right 3. And then our last thing is we have a negative here, so that's going to flip it. Okay, it's going to flip. This is a square root, so it'll be like a U, except we're going to flip it, so then it'll be like that. So back to our table. 2 was an error. 3, we're at 2. At 4, we're at 0. At 5, we're at negative 0.8. At 6, we're at negative 1.5. And at 7, we're at negative 2. We can just count by ones here on this graph. Don't need to change anything. Go over to 3, up 2. Okay, go over 4, up 0. Over 5, down almost 1, but not quite. Over 6, down 1.5. And then over 7, we're down 2. So hopefully you can see that this is that U shape. It is stretched out because of that times 2 out front. So it looks something like this. So now our domain, like I said, it's going to change. Our domain is all possible values of x. So you can kind of think of it from here over, okay, as our values of x that are allowable. So we can say this time it's not x greater than or equal to 0. It's going to be greater than or equal to 3. Likewise for our y, y's now are anything under this, right? So our y, this time we're going to say less than or equal to. Y is anything less than or equal to 2. Okay, I look over here at this y value. Okay, and that's our domain and range, and this is our explanation of the transformation, which I asked for on this worksheet as well. All right, the next one. We have a cube root now, okay? So the cube root is that stretched out s. It's going to look something like that. This value is positive, so it doesn't flip it. This right here, this plus 4 inside that cube root is going to move it left 4. And then the minus 1 right here will move down 1. So it's going to move that whole squished s over 4, down 1. This will stretch it out as well. So you could put stretch. I wouldn't mark it wrong if you didn't, but it's good to know that we'll stretch it out. All right, for our table, again, I apologize. We're going to have to change some values. And this is not the correct function for it. Just erase these with a white pencil. All right, so when you're typing in the cube root, remember that's in your math menu. I think it's number 4. So 3 times the cube root of x plus 4, and then make sure you scroll out of your cube root, minus 1. And then we want to go to our table. For this one, I want more negative values of x, which is why I needed to change my table. So actually, I'm going to start at negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, and negative 1. All right, so in my table, negative 7 is at negative 5.3, negative 6 is at negative 4.8, negative 5 is at negative 4, negative 4 is at negative 1, negative 3 is at positive 2, negative 2 is at 2.8, and negative 1 is at 3.3. Okay, so again, we can count by 1 here. I'm going to go over to the left 7, 2, 4, 6, 7, And then I'm going to go down 5. 1, 2, 3, 4, 5, and then a little more because it's 5.3. All right, next one, down, or to the left 6, down 4.8, so almost 5. Then down, or to the left 5, down 4. To the left 4, down 1. To the left 3, up 2. To the left 2, up 2.8, so almost to 3, but not quite. And then to the left 1, up 3, and just over 3. So you can see this is definitely a stretched out S. Okay, looks something like that. Remember, the domain and range are really easy for cube roots, and that doesn't change even with these transformations. It is all real numbers. Everything works for cube roots. Range, all real numbers. I know you guys like shortcuts. There is an abbreviation for all real numbers. It's this fancy R. Okay, so if you wanted to put that instead of all real numbers, you could just put that fancy R. Last one. All right, values are good for this one. So you just have to type in the cube root of x minus 5. Just make sure that minus 5 is outside of your cube root. The only transformation happening here is that minus 5 is going to move this whole thing down 5. So if we look at our table, negative 2 would be at negative 6.3. Negative 1 is at negative 6. 0, we're at negative 5. 1, we're at negative 4. 2, we're at negative 3.74. So let's go ahead and graph this. At 0, we're going to go down 1, 2, 3, 4, 5. Notice here, it's interesting, at 0, you're down 5, because remember, normally at 0, it would be at 0. So that's that part that actually got moved down 5. At negative 1, we're at negative 6. At negative 2, we're at negative 6.3. Okay, so that's our left half. Now at positive 1, we're at negative 4. And at positive 2, we're at negative 3.7. So almost to negative 4, but not quite. This was not stretched out, so this is really a shallow kind of looking S. Like that. Okay? And then our domain and range, if you want to use that shortcut, you would just write like that. You don't have to. You can still write all real numbers. Whatever you'd prefer. You don't have to write both, but I'm just going to for our notes, just so everybody's on the same page. So your homework that goes along with this part, your next homework that's due, is actually a matching worksheet. And then you're just going to name the transformations. You're going to describe the transformations like we did up here, okay? And then you're also going to state the domain and range. Remember, the domain and range are only different for square roots. For cube roots, it will always be all real numbers. If you have any questions, let me know. Remember, I have office hours every Tuesday from 1 to 2 on Zoom. And then I'm available by email always.